Hey everybody, this is Larry. This is day 10 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And of course, it seems like today's problem is another binary search problem, which is kind of frankly, it makes this format very silly at this point. How much more can I say about binary search? It is good practice, so I don't want to dismiss it as I don't want to dismiss it for people who might be struggling still with binary search, and you're getting your whoops on and stuff like this. Is that a phrase? Getting your whoops on? Huh. Anyway, I don't know if that's a phrase, but hopefully you still know what I mean. But as I always keep saying, half of half of the difficulty on a binary search problem is that recognizing it as a binary search problem. Maybe some percentage, maybe may not be a perfect half. And knowing that it is binary search kind of takes out some of the fun of kind of looking into it, even thinking about it. Right now, I'm just kind of almost like in mechanical mode. And if you're watching this video for the first time, like on this channel for the first time, I apologize if I'm not saying anything that helpful for this problem because, I don't know. We've been saying everything the last couple of days, and it's at some point, I don't know if it's repetitive or not, or you just don't come back. I don't know. Right. So, yeah, let's take a look at this one. I don't know if this is the truth, but it seems like I got search and motivated away too. So, yeah. Okay. So, I think, is this the same one that we did the other day? What was it? Yeah. So, it's the same one except for not distinct, right? So, I mean, yeah, you could talk about it. I think we've talked about this in the past as well. The short answer is, you could, the idea that I would think about is just thinking about the worst case, right? And the worst case is maybe if all the numbers are the same or something like this, or yeah, and obviously that'll be a degenerate case because if your period or if your middle element is the same as your first element, or depending on how you do it, where you cannot, core part of binary search is this divide and conquer thing, where you bisect, if you will, the search space into half every time, or approximately half every time, and in this case, because your one bit of information doesn't give you an actual bit of information to bisect, it can at worst be linear time if you're doing okay, and maybe worse if you're not. That's basically the idea. I don't really have much to say about this one other than that. Or at least what I mean is I don't have anything to say that I haven't already done in this problem, and this was 2 days ago, so you probably could find on my YouTubes what I said about this 2 days ago. Yeah, I don't know. Yeah, you can kind of special case these things. I think the thing that adds a little bit I think that's the thing where and I don't know. In terms of like what happens on an interview, a lot of these things to me right now, for this particular problem, just feels like a little bit of mind reading, right? And what I mean by that is that you can decrease overall operations, but that could mean anything. You can say, oh yeah, maybe for this case it'll be better if it's not degenerate. Yeah, but then but the truth is you are having a degenerate case, right? And then the solution isn't necessarily like if you try to build generic general solution, that's not what you're trying to do, or that's not what you should try to aim to do. What you should try to do in the real world, if is that maybe don't build a generic general solution, right? Maybe your inputs are not equally distributed, right, or evenly distributed in a way, right? It's not, you're not getting if you're getting random input, then yeah, maybe you can say that in some random world, who knows what the random means? How often do things become non-unique, right? How many times there are repeated numbers, right? And then in that case, yeah, maybe you can optimize for that. But in the world, it's very often not evenly distributed. A lot of things, a lot of inputs, a lot of data sets and stuff like that. And the goal there would be to optimize for that data set, right? Meaning, I mean, for this particular problem, it's tricky to really come up with that many variation on data sets. But you can think about like doing NP problems, and the problem is, and then the solution isn't to. I mean, there are a couple of possible solutions, right? Which is to kind of figure out a subset of the solutions depending on your data sets. Like for example, if you have TSP, traveling salesperson problem. Maybe the generic one for any graph is ridiculous. But what if you have a variation that is on a planar graph? Well, then now there's some optimizations that you can do. There's some, triangle inequality and assumptions, right? So there are a lot of things that you can do to kind of cater your algo to a particular data input if you're able to know what the data input is. For example, maybe there's some real world things even, right? Like, and this goes with just general optimization stuff as well. Is one, don't prematurely optimize, and two, if you're gonna optimize, figure out the time your code is spending, so you can optimize specifically for that code, right? For example, if I don't know. There are a lot of examples. I'm just like blanking a little bit off my head. But maybe you know that there's some characteristics about your inputs that you can optimize for. Then you should definitely do that, right? Here it's just like, decrease overall operation. That means nothing. I mean, like maybe like in a extreme example, like maybe it's just search, but only one number is different, right? Maybe you have two different distinct numbers or something like this, right? Then maybe then that changes a lot of things, right? Because then now maybe you could even, like, let's say half the numbers are one and half the numbers are the other number, and you're trying to see if whatever number you exist in two of them. Well, then all you have to do, there's even like a probabilistic algorithm with that, just off my head, right? So there are a lot of like funky, tricky stuff, but you can, like, it's a silly problem to optimize in a general sense if you know that the worst case, or like, you're prematurely optimizing if your worst case analysis is going to be this, right? Like in another example is, let's say you do code force or something like this, and your code will be challenged by someone, or what do they call it? Hack? Yeah, like hacked by someone or something. Well, it doesn't matter how many things you optimize. You're only going to get inputs that are the worst case for your code, right? In that case, then what are you really doing, right? It's a very long-winded answer, but maybe that is actually what an interview would actually use with this, because the real world is nuanced and the real world has a lot of implications. The real world has a lot of weird edge cases, and the real world does have some natural characteristics, right? Like, even when we talk about random, maybe there's some like central limit? Yeah, central limit theorem type things, or large or law of large number things that you can exploit. Not with this number per se, but there are things like that, right? This is how you get like binomial distribution and stuff like this. Even though quote unquote is even, and that's how you get normal distribution instead of even distribution, right? Just random things happened a lot of times, which is, central limit theorem and all this stuff. I'm not going to get into that, so sorry if I'm dropping a lot of vocabulary, if you don't, if this is not, not something that is relevant for you. But my point is that this problem is silly. Maybe that's a really long thing. And the only thing that you may maybe have some interesting thought experiment about is the fact that maybe it's binary search, or some component is binary search. But like I said, putting this in the binary search section kind of defeat that quite a bit, in fact, right? So yeah. As I always say, these videos, just to be clear, I don't know if I'm going on for a bit, because I think I've been talking for about 10 minutes. Everything is unscripted, unprepared, so it's kind of, so everything I talked about is kind of just speaks to a bit of disappointment that I have in this problem. That's all. And some of these problems, I suppose, are meant to be like a one-on-one person thing, where you talk to the interviewer and you're like, okay, well, in this case, and then you go back and forth, right? But of course, on paper, on Leetcode, on these things, there's really no conversation. There's just, you do what you can, right? That's all I have for this one in terms of conversation. I'm a little bit lazy, so what is there to say, right? Let's implement some funky things for this. Let's just say, Yeah, let's do binary search kind of, but recursively. I feel like I haven't done much of binary search recursively, so it's just kind of for me just like a funky thing to do, and just like play around. I think to be honest, also if you really want to understand binary search, well, I mean there are a lot of ways to do it. It's well, maybe not. Maybe I phrased that. Eh, maybe I exaggerated what I mean. But what I want to say is that if you have a good understanding of these things, you are able to kind of play around and maybe, just maybe the recursive solution is something that is, maybe understanding the recursive solution unlocks just binary search for you if you're having trouble, right? So let's try that. Maybe today we try something funky, and for this particular problem, I think there is for this particular problem, I think there's a natural way to kind of break ties, if you will. So I think that keeps it, maybe okay. I don't know if breaking ties is the right word, but yeah. So basically here we go, maybe find 0 and n-1, right? And now here our binary search with left and right. Again, the way that I always like to do it is just, well, one is define things, but it's going to be just left, right, inclusive. You can do whatever you want as long as you define these things, and then you can check and debug your code so that they're consistent to your definition, right? But if you don't, then well, not so much. But yeah, or this is where you get off by 1, and you're like, why is this off by 1? Because like maybe in one line of code you're like, oh, this is inclusive, but the other line of code you're like, oh, it's not, right? So okay. So yeah, so mid is equal to left plus right. We choose the middle, and then here we want to say the same thing we had in the other problem. Right? Am I looking at the right one? Okay, yeah, just in case I was writing in the wrong one by accident, right? So so basically we have, I think the way that we wrote it is just that if okay. So and num submit, we have these two numbers that we're checking, and we're checking to see if this function is if with target is between num sub 0 and num sub mid in a way, right? I mean, this is one condition. There are another condition, as you know. Then we can say if find of left mid, then we return true, right? It's a kind of an awkward way of phrasing it, but the reason is because that's not the only way that can be true, right? So that's basically the reason why. And then the other case is if, and I think we kind of wrote it the other day, right? Like here, right? So yeah, but it's fine. So otherwise, if num sub 0 is greater than num sub mid, then now we try to figure out whether, you can kind of think about it as wraparound kind of thing. So it's almost like the opposite of the other thing. This is actually, I don't think I said it last time, but it turns out to be just like the what's it called? De Morgan? I think it's De Morgan of this thing, where it's just not this becomes this, even though it looks kind of funky. So basically, if this is the case, then we choose that it has to be the outside, right? So maybe we can just write here. And then if find left mid, right? So these are kind of equivalent, and then we're going to return true, saying that these are in the middle. Yeah, the way that I wrote these is kind of awkward. Definitely there are ways to kind of combine these for sure. I'm just going to keep it this way so that we can kind of go over it, right? Or like, so that you can kind of understand how we get to each one. And then now the cases that we check on the other side then, right? And actually we can even do it here, which is that if this is outside, if this is outside the target, even though it is in the order. I mean, and one way to kind of what I like to do if you're having trouble, and maybe I don't know that I have trouble, but I think I'm not explaining it well enough, is that if you kind of just like use some examples, and then you're like, okay, well, if the target is 10 and mid is greater than 1 and 10 is not inside, then we have to look at the right side. So then here we look at the right side, and we do this recursively, right? And also, of course, maybe if left is equal to right, then we're searching one element. Return true if num sub left is equal to target, we return true. So we can actually just return this, I think. And then the other case is if for whatever reason, I think just for sloppy, I don't think that's possible, but maybe I'm wrong. Then we just return false, right? We're searching nothing. And the same thing goes here, right? Is that if we have the opposite case, then now what happens if, you know, and this case, maybe as I said, you could come up with some examples. So now you have something like the number is like 5, 6, 7, 8, and then your middle number is 1, and then now you're trying to find your target X, whether it's inside these. So then now here you go if yeah, then it has to be on the right side, which I guess is actually the same thing. So then we return true, and then otherwise we just return false. Even though this looks very yeah, very straightforward, you know, divide and conquer, the thing that's notably different is actually that we kind of made it so that it's possible to search both halves, because there is a scenario in which we search both halves, right? Especially I think maybe I have to actually double check my carefulness here, because the way that we wrote this is because the way we wrote this is assuming that the numbers are still unique. So I think maybe I'm a little bit bad here on this case, to be honest. So let's kind of think about this for a second. But the general structure is kind of right, I think. Like I said, there may be some silliness, but with off by ones and stuff like this, because I actually didn't think about the Leetcode case. So we have to think about it, right? The reason why this is a little bit tricky is that you have to search both halves if mid is equal to nums. So I think in this case, I think we just have to change this to this, because because the only weird case is if the mid is equal to nums, and in this case, if mid is equal to nums here, is that I think it's very tricky, to be honest, especially the way that I kind of construct it. I think there's I think the problem is that I did this implicitly. I think that what I wrote is something like right, and then if I did something like that, then that would maybe be more symmetric in our code structure. And I think this now maybe makes sense. Yeah, I think this makes sense now. Yeah, wait, maybe this one doesn't. It's not. Let me double check. So if they're equal or greater, but if they're equal, then I think this should be here, so that if they're equal, then you also want to check the right side. Because if I had it as equal, then it would still also only check the left, maybe, or not even check at all. Yeah, I mean, these test cases are kind of crap, right? For these kind of things. Yes, that's why I'm testing these. There's a case where we don't reach all the possibilities, and I think, and it is what I suspect, which is why I kind of tested this, is all these eco signs, which is a little bit tricky. Oh, I see. I'm messing this up. Um, I think I'm just being dumb. I mean, I think I'm mixing two definitions for this particular one. And what I mean by that is that is that I'm using zero, so I'm not really searching whether I'm like my definition here is not actually the same definition I have here, which is that return the smallest index between 0 and index. What I'm doing is actually, I think in my dot, though I didn't implement it this way, is that I'm actually seeing whether the number is between left and right inclusive, which is not the same as checking to see if the number is between 0 and left inclusive in such a way that left is the smallest index. So actually what I needed to do is kind of, convert these to left or something like this. And then I think now maybe it should be slightly better. Still wrong on this one, so which is unfortunate. And yeah, that's fine. I think the thing you do then is just doing some debug, right? And the idea behind this one is that you should definitely look at every cell, and apparently it doesn't. So the inclusive recursion is 0 and 7, and 4 and 7. 4 and 7. So actually 0, 7 is already messed up, right? Because 0 and 7, it doesn't do a recursion on 0 and 3. Yeah, why doesn't it go to 0 and 3? So basically, this should be true in the first iteration, and then this is not true. Oh, so because the equal signs. Yeah. Because the way that I've thought about equal sign is that it has to be in between, and I'm thinking of the Python shortcut. But if they're equal, then what happens is that it can. The thing is that if they're equal, and maybe that's what I should just do instead. Yeah, let's do it this way. I think what I try to do is too sneaky. What happens is that if mid is equal, is that you really don't know any information, so actually you have to do a recursion in both half. I mean, I could still write it in such a way that this is true, but I think the way that I wrote it is a little bit awkward. So yeah, so then now we return find left mid, or find mid plus 1, right? Something like this. I thought I was trying to be, I think I was trying to be too clever. And I think one thing, hopefully, that shows up is that, there you go. If you find yourself being too clever with your code, which sometimes I do, to be honest, from time to time, just dumb it down. It's okay. I mean, right now, or dumb it down in a way such that you get the right answer, and then afterwards you can build on that step by step, right? Like here now we could like, okay, maybe we could refactor it such that like if this is equal, then we do certain things, but I'm not going to, but in theory you can. So yeah. Cool. As you know, this is going to be in the worst case linear time, linear space. That's kind of well. Well, I mean, for me, my code is going to be linear time, linear space, and I even had an extra print statement here for extra good luck, actually. It didn't actually make that fast enough. I guess there are not that many inputs, but yeah, the way that I did it is linear time, linear space. Actually, I think this is still in the worst case log n space because of we do divide and conquer at worst. So the stack space is actually at worst only log n. I don't think I mean, maybe, because I think due to rounding, maybe I'm sloppy with the rounding. It could be a little bit overband. Not quite sure about that one. Either way, both are suboptimal versus the iterative approach, because you can just reduce it to all one space, which, maybe I recommend you do. But yeah, otherwise, log n, linear, and, and a new funky way to write it. Try to play with myself too much. That phrasing is really wrong. But yeah. Wow. Past Larry also did it this way. That is really weird. But also did it. Wow. Past Larry. What about the other time? I guess that time I really just went case analysis. Alright, well, I see what I did, but that's funky. Anyway, that's all I have for today. That's all I have for this problem. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.